guess we should talk about the word again. What does it mean to eliminate? What was that? Get rid of. Cancel it out. You bet. So when I look at an equation, sometimes it's all good and ready for elimination. Sometimes it's ready for substitution. Sometimes it's ready for graphing. Okay? Again, graphing, we want y equals mx plus b. Substitution, we want an equation solved for x or solved for y. Elimination, sometimes it's set up for elimination if you see a positive, negative, same number in front of the variable. So see where I have a 4y and a negative 4y? This is set up for elimination. Okay? Canceling out, getting rid of something is that word elimination. So when I look at this, this is set up nice and neat for elimination. If I were to add the two equations together from the get-go, it's going to cancel out or get rid of those 4 y's. So those are gone. If I do the math here with my x's, negative 7x, positive 4x, what do we have left when you do the math? Negative 3, is that right? I have an equals here, so that's still there. And when I do 24 plus 0, what do we have? 24. We then say, okay, now I'm just solving for x. How do I solve for x? You bet. And what are we dividing by? Negative 3 on both sides. Negative 3 divided by negative 3 leaves me with my x. The equals is still there. What's 24 divided by negative 3? Negative 8. There's one of my answers. Remember when we're solving this, it does not matter if we are graphing, if we are using substitution, or now elimination. We're looking for an x comma y. Usually they are going to be an ordered pair. So right now I have x. What do you think, to solve for the y? What did we do before? What did we do in that substitution method once we had one variable? Plug it in, which is substitution. So elimination is partially substitution. We're going to take that x value and we're going to plug it in where I see an x. I can go here into that top x, or I can go into the bottom x. It does not truly matter which one you plug it into. As long as we do correct work, we get the same answers. Do we want to go in the top x or the bottom x? Does it matter? No. So, should we do the top one? Sure? Let's do it. All right. So, we're going in right here. And instead of that x, what are we plugging in its place? Negative 8. So we have negative 7 instead of x. Negative 8 plus 4y equals that 24. If somebody would have said plug it into the bottom x, I would have been okay with that. Now we're just doing the math. So when we look at that, what do we do first? Multiply. So negative 7 times negative 8 is really what? 56, you bet. Plus my 4y stays 4y. That 24 is still 24 on the other side. Now what do I do? Very good. Subtract the 56. What I do to one side, I have to do to the other. That's the algebra of it. I am running out of space, but I'll just erase my little ordered pair here. All right, so 4y equals what is positive 24 minus 56? Negative what? 32. 32? Good math. Last step. Divide by 4. What I do to one side, I do to the other. And negative 32 divided by 4 is negative 8. We just found our solution. Again, how do we write our solutions? Very good. X comma y. In this case, does it truly matter? Not really, because they're the same answer. Does that happen? Not very often, but sometimes. Sometimes it will. And there's our solution. All right, so we just found a solution of negative 8, negative 8. Are they always going to be set up for elimination? Not always. Again, the telltale sign that this was ready for elimination, we had a positive 4y and a negative 4y. The positive, negative, same number makes it ready to go for elimination. If I turn it over to the front side, we still had a couple examples there on 6 and 8. Neither one of those are set up for elimination, but we can still use elimination because it's not set up for substitution. Okay? Any questions here what we did? All right, let's go ahead and look at number 6 as another example of elimination. Elimination because we need a positive, negative, same number. So if I was choosing my x to eliminate, I would need a negative 4x in front of this down here. If I was choosing my y to eliminate, here's a positive 2y, I need a negative 2y down here. You need a positive, negative, same number in order to use elimination. Now, when you go to do this, because it's algebra, there's more than one solution, more than one way to get to that solution. So if somebody were to choose x, then they're going to multiply through this bottom equation by negative 4. If somebody says let's choose y, then we're going to multiply this bottom equation by 2. Okay? So again, there's more than one correct way of getting to an answer if algebra is involved. Which one do we want to get rid of first, the x or the y? The y would be a little less work. I agree. Okay? So, if we choose y, then we know we have to have a negative 2y in front. We already have the negative, right? Correct? There's a negative there. So all we have to do is say, okay, let's multiply by 2. And what we do to one thing, we have to do to everything in that equation. Okay? So again, choosing y, all we have to do is get that negative 2 there. Well, it's negative already, so we're going to multiply by 2. I'm multiplying everything in that equation by 2. And then I'm just going to go over here so we can see what we did. 2 times x, 2x, good. 2 times that negative y. And then 2 times my 13 really gives me what? 26. Good math. That top equation I didn't change, right? I'm not going to change that, but I am going to rewrite it so that it's all up, down, and it looks all nice and neat and pretty and ready to go. We didn't change the top one. Okay? So now, since I have a positive 2y and a negative 2y, I can add them together. eliminate or cancel out or get rid of those y's. How many x do we have when we add them together? 6. We do have an equals here still. 10 plus 26 really gives me what? 36. Last step. Divide. And what do we get as our x answer? X equals 6. Good math. How do we find that other answer again? Plug it in. Substitute it in for the x of the original equations. Again, I can go into the top x or the bottom x. It does not truly matter. Do we want to go into the top or the bottom? I didn't hear.
Bottom.
Bottom? Sure. If somebody said top, is it wrong? No. You can plug it into either one of those original equations. I'm going to go into the bottom one. A little less work maybe. I'm not for certain, but I'm going in for x. So instead of x, I'm substituting in 6. Subtract that y equals 13. We're trying to solve for y now, so what do we need to do? Sure. Subtract 6. What I do to one side, I have to do to the other. Positive 6 and negative 6 go away. I still have that negative with the y, though. And 13 minus 6 is really what? 7. And again, remembering that this is really negative y, which is a negative 1y. How do I keep solving for y?
Divide by -1.
Very good. And what I do to one side, I do to the other. Y equals, hope you're going to say negative 7. How do we write our answers?
X comma y.
Very good. X comma y. So our solution would be what?
697.
Very good. And there is our solution. All right, so looking back and reviewing what we just did. We had our original equations. We chose to eliminate y, so we had to get a negative 2 in front of this y up here because we want positive 2, negative 2, so that they eliminate or cancel out or get rid of the y's. Okay, you could have chose x, but we chose y, solved for x, plugged x back into the original equation, got an x and a y. Okay? Any questions there? Let me see if I can find a better example here.